As the inevitable growth of transport electrification continues, the types of batteries that will be used in such vehicles, their charging parameters, infrastructure and timeframes are key considerations that will speed up the transition to electrification. In the paper, Determining the Limits and Effects of High-Rate Cycling on Lithium Iron Phosphate Cylindrical Cells, published in and on the cover of the journal Batteries, researchers from WMG, University of Warwick investigated the impacts on battery cell aging from high current operation using Co. They used two tests to establish the maximum current limits before cell failure and applied this maximum current until cell failure. Testing was performed to determine how far cycling parameters could progress beyond the manufacturer's recommendations. During testing, current fluxes were increased up to 100 C cycling conditions. Charge and discharge current capabilities were possible at magnitudes of 1.38 and 4.4 times, respectively, more than that specified by the manufacturer's claims. This increased current was applied for 500 charge-discharge. However, the application of these currents resulted in a rapid decrease in capacity in the first 60 cycles as well as an increase in resistance. Furthermore, the application of such currents resulted in the increase of cell temperature, during both charge and discharge with natural convection during the rest step cooling the cell. Batteries operate in an optimum temperature range, and any deviations outside this can cause components and chemicals to start decomposing inside them. Lead engineer, Justin Holloway, from WMG, University of Warwick comments, Justin Holloway, WMG, University of Warwick, the testing showed there is a window for operating batteries above manufacturer-stated current limits, however, whilst maintaining manufacturer-stated voltage limits. We need to ensure that batteries operate in as the safest manner possible, and for an appropriate practical lifetime, which is why the manufacturers have these limits. We also identified thermal fatigue as the driving mechanism for jelly roll deformation. With each cycle of charge and discharge, the cell experienced thermal stresses causing deformation of its components. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.